Okay, so we're going to talk about the next three sections of chapter 4, 4.2 to 4.4. This is essentially our big ones. Now, the reason I'm doing it all together is because a lot of it goes together. Um, it's trig with triangles and with circles. So it really introduces it in depth. So kind of take a little bit of each section, kind of make it into one mega section, so to speak. So you have the idea of a right triangle, which is, three-sided figure. The sum of the three angles inside a triangle add up to 180. Just a couple of things here. The two shorter sides have to add up to more than the bigger side. The bigger side is a hypotenuse, opposite of the right angle. If you have an interior angle that you're dealing with here, in this case we're calling it theta, then the side that runs next to him is the adjacent side, which we call ADJ for short. The side that goes opposite of him is his opposite side, so we call it opposite OPP for short. And the hypotenuse of a right triangle, we call it the hypotenuse, or HYP for short. Trigonometric functions, essentially what's going to be a lot of what we do this semester. Pretty much the first four exams are going to deal with these trig functions over and over and over. Now, they're the ones that come out here, sin, cos, tan, the one you see here, and then you see -1 power, which is their inverse. So trig functions. Sine, cosine, tangent, cosecant, secant, and cotangent. Get very familiar with those because that's what we're going to do a lot of this semester. The abbreviations here are in red. So sine is SIN, cosine is COS, tangent is TAN, cosecant is CSC, secant is SEC, and cotangent is COT. So this here, get familiar with this. This is these are the ratios. These are your trig functions. So sine is understood to be, sine of theta is understood to be the opposite side divided by the hypotenuse. Cosine is the adjacent side divided by the hypotenuse, and tangent is the ratio of the opposite side over the adjacent. Cosecant is hypotenuse over the opposite side, which is the reciprocal of sine. So cosecant is understood to be the reciprocal of sine. Cosecant is the hypotenuse over the adjacent, which notice it's the reciprocal of cosine. So secant and cosine are reciprocals of each other. Secant and cosine are reciprocals of each other. Cosecant and sine are also reciprocals of each other. And then as you can tell, also tangent is adjacent over opposite. Opposite over adjacent is tangent. So tangent and cotangent, these guys are reciprocals. That's why you see them written in the same row here. So tangent and cotangent are reciprocals. Cosine and secant are reciprocals. Sine and cosecant are reciprocals. If I look at just this part of it, this left part of it, you see how sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So SOHCAHTOA is a mnemonic way to remember these three trig functions. So, ka, toa. The reason you don't see this as a mnemonic device is because if you know that sine is opposite over hypotenuse, then cosecant has to be these two letters reversed. Hypotenuse over opposite. If you know that cosine is adjacent over hypotenuse, secant has to be hypotenuse over adjacent, these letters turn around. And if tangent is TOA, opposite over adjacent, cotangent is AO, or adjacent over opposite. So knowing these three, you get these three essentially for free because you just know you just have to figure out, just remember the relationship. So using that idea, you're just getting pieces of right triangles here. If you're given the side, if you're given a theta here, and you're given that its opposite side is 5, its adjacent side is 12, and its hypotenuse is 13, then the idea is, how do we get the trig function? So sine of theta, so opposite divided by hypotenuse. That's why I get 5 over 13. Cosine, adjacent over hypotenuse, 12 over 13. And then tangent is opposite over adjacent, TOA, 5 over 13. Now cosecant is hypotenuse over opposite, 13 over 5. Or if you know what sine is, cosecant essentially is for free. You see how it's reciprocal. If you know cosine, secant is its reciprocal. You just flip the fraction. Same thing with cotangent. So once you get these three, essentially the other three follow if you understand this relationship or the relationship. So if you're given a second triangle with these sides, if theta is over here, sine is opposite over hypotenuse. Opposite over hypotenuse. So 3 over the square root of 13, but that's the answer, but we don't want fractions. We don't want square roots on the bottom of the fractions. So we multiply by the square root of 13 over 13. We multiply by the square root of 13 over the square root of 13. We rationalize. So we multiply any square root times the same number inside becomes the square root of 169 here, or becomes itself 13. Because this is the square root of 169, which is just 13. So in other words, the square roots cancel. Same thing for the cosine. Multiplying by square root of 13 over square root of 13, you get 2 square root of 13 over 13. I'm sorry, I didn't even cosine. Cosine is cot adjacent over hypotenuse. So that's what I'm getting 2 over 2. Tangent is opposite over adjacent, TOA, 3 over 2. Cotangent is the reciprocal of tangent. Now looking at secant, cosine was 2 over square root of 13. Now secant is hypotenuse over adjacent. So square root of 13 over 2, or the reciprocal of the original cosine. Cosecant is the reciprocal of the original sine. And that's how you get these values. So, ka, toa. Reciprocal, reciprocal, reciprocal. If you're given two sides and you look for the opposite side, hypotenuse here, in fact, if this wasn't given, to find the missing side, use the Pythagorean theorem. Just want to do an example like that. So 3 squared plus 4 squared equals h squared. H is then the square root of 25. H squared is 25, so h is the square root of 25, which is 5. So in case one of the sides is missing, just use the Pythagorean. Find the missing side, and then do SOHCAHTOA. Sine, opposite side of that theta, the given angle, divided by hypotenuse, so 3/5. Cosine ka, 4 over 5. And tangent, opposite over adjacent, 3/4. So if sine is 3/5, cosecant is 5 over 3. If cosine is 4/5, secant is 5 over 4. And if tangent is 3/4, cotangent is 4 over 3. And that's how this works. What we're going to do now is we're going to incorporate special right triangles. And this is essentially the root of what we do this semester. Okay. So we have 30, 60, 90 triangles, or 30, 60 right triangles, and 45, 45 right triangles. When you do a 45, 45 right triangle, it's isosceles. So these two are congruent, and you use the Pythagorean theorem to find that side. So the two sides are x's. The hypotenuse is x times the square root of 2. So whatever x is, you put into this little formula, and that's how big you want all these triangles to be that fit 45, 45 right triangles. Or 45, 45, 90 triangles. In particular, when x is 1, 1 and 1 here, and this is 1 times the square root of 2, or just the square root of 2. So this triangle, get familiar with it, because we're going to do a lot of this semester. When the 60-degree triangles, it turns out that the 30-degree side and the hypotenuse are related to each other by double. The hypotenuse is double the size of the opposite side of the 30 degree. So x, 2x, Pythagorean theorem gets x squared root of 3 for the opposite of the 60 side. When x is particularly 1, you get 2 as the hypotenuse, 1 is the opposite of 30, and square root of 3 is the opposite of 60. 1's here, and the square root of 2 is the hypotenuse. So these are very, very important. We're going to use these two over and over and over so many times this semester, not even funny. So if we take this angle, it doesn't really matter which of the two, but they're the same value. So 45. Sine of 45 is so opposite over hypotenuse, 1 over the square root of 2. But again, you have to get rid of the square root on the bottom, so square root of 2 over square root of 2 cancels the bottom, makes it just 2, so square root of 2 over 2. Cosine, adjacent 1 divided by hypotenuse square root of 2. Same answer as sine, because there's isosceles, so square root of 2 over 2. Okay, now tangent is the opposite side, which is 1, divided by the adjacent side, which is also 1, so 1 over 1. Cotangent is going to still be 1 over 1, so it's still 1. Secant will be square root of 2 over 1, which is just square root of 2 again because of reciprocals. And cosecant would be the square root of 2 over 1 because of reciprocal of sine. So these 6 trig values work for 45. Or for 45 degrees. Now, when you're talking about 30, the 6 trig values of 30, here's 30. Its adjacent side is square root of 3. Its opposite side is 1. The hypotenuse is 2. So sine of 30 is so opposite over hypotenuse, 1/2. Which means the cosecant of 30 will be 2 over 1, or just 2. Cosine of 30 would be adjacent, ca, over hypotenuse, square root of 3 over 2. No square roots in the bottom, we're good. Secant would be its reciprocal, so 2 over the square root of 30, or hypotenuse over adjacent. So we have to fix this up, so to speak, multiply by the square root of 3 over square root of 3, and we get 2 times the square root of 3 on top, and then just 3 on the bottom. Tangent is opposite 1 over adjacent, TOA, square root of 3. So multiply by square root of 3 over 3, you get square root of 3 over 3. Square root of 3 over square root of 3, excuse me. You multiply the bottom is just 3, the top is just square root of 3. Cotangent is the reciprocal, or adjacent over opposite, which is the reciprocal of 1 over square root of 3, which is square root of 3 over 1, which is square root of 3. So these are the 6 trig values of 30. Now 60. If this is 60, then its opposite side is the square root of 3, its adjacent side is 1, and the hypotenuse is 2. So looking at this, opposite over hypotenuse, sine, square root of 3 over 2. Cosecant is the reciprocal of that, or 2 over the square root of 3. So we fix it up like we did these other ones, and we get 2 square root of 3 over 3. Cosine of 60, ca, adjacent over hypotenuse, 1/2. Secant, therefore, is the reciprocal, 2 over 1, or just 2. Tangent, coa, opposite, square root of 3, adjacent 1. Square root of 3 over 1 is the square root of 3. And the cotangent is 1 over the square root of 3, which we fixed up by multiplying by rationalizing. You get square root of 3 over 3, square root of 3 over square root of 3. We multiply, we get the square root of 3 over 3. So notice that the sine of 30, excuse me, notice that the sine of 30 and the cosine of 60 are the same. The sine of 60 and the cosine of 30 are the same. It's because the opposite of one side is the adjacent of the other. So that's why these two numbers are inverted. As are these numbers. Tangent of 60 is the cotangent of 30. Tangent of 30 is the cosine of 60. These guys invert. Secant of 1 is the cosine of the other. Cosecant of 1 is the secant of the other. Not a big deal. I just wanted to point that out here. So the importance of this is that now we know how to get the 6 trig functions of these 3 important angles that we're going to do this whole semester. So you have 30, 45, and 60. So it turns out that essentially any angle has the same trig functions as any of its reference angles, assuming that there is one. Assuming it has one. So the ones that live on the x and y axis that don't have any reference angles, I'll show you how to do those in a while. But the ones that end in one of those 4 quadrants and do actually have a reference angle, we can now find its trig values by actually figuring out the trig values of its reference angles. As you can see, since we're doing 45, 30, and 60, we're going to look at angles who have a reference of one of these 3. So we can build off of this. And so that's the gist of trig. So if you look at 210, look at example 1 here. 210 lives in the third quadrant, quadrant 3. So you notice that it passes the 180 by 30 degrees. So its reference is 30. Its reference is right here. So we make a little right triangle there, 30. Then because this adds up to 180, this has to be 60. So this triangle is really just this triangle upside down. So we get the pieces. The reason 1 is negative and square root of 3 is negative because x is negative and y is negative. Hypotenuse here will always be positive because this is kind of like, this will turn out to be the radius of a circle in a while. However, you can take these two guys and square and add them. This has to be positive. So this guy coming diagonally will always be positive here. Hypotenuse, essentially. The adjacent and the opposite sides, depending on what quadrant you are, will be positive or negative. So now we look at this and we say, look, this is 30 degrees. So the sine of 210, the cosine of 210, the tangent of 210, all the six trig values of 210 should be the same as the six trig values of 30. So these six answers will be these six answers if you look at it carefully, because you're in the same triangle. The only difference is over here, sine is negative because it's opposite over hypotenuse. So here the opposite is negative and hypotenuse is positive. Cosine is negative because the adjacent is negative and the hypotenuse is positive. Tangent is positive because both the opposite and adjacent side are both positive. When you take it reciprocals, the reciprocal of negative will still be negative. The reciprocal of positive will still be positive. So ultimately, see, this is the same six trig functions as the 30, with the exception that what? 4 of them are negative and 2 of them are positive. So these 4 are negative. So really the only one that's positive here is tangent. And it's reciprocal cotangent. So in the quadrant number 3, only tangent and cotangent are positive. But they're the same six answers. Because essentially you're in the same triangle, except the adjacent and or the opposite side could be negative, depending on where you are. So if you look at quadrant number 2, if you look at example number 2, if I look at the rate 3 pi over 4, you're like, well, how the heck do I do this? Well, 3 pi over 4 is 135 degrees. Remember that? Because pi over 4 is 45. This is 3 of those 45, which is 135. So 3 pi over 4 is in the second quadrant. Its reference is 45 because it's 45 degrees short of 180. Again, if you will. Or now you can actually call it radians. So this is actually pi. Again, pi over 2, pi, 3 pi over 2, 2 pi, because you're going by 90s. By 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. That's how you go by 90s. So you're looking at these values, then if the reference angle is 45, then these sides are like this. 1, 1, square root of 2, but except this one is negative because you're on the negative x-axis. So the answer, if I'm looking for the six trig functions of this guy, 3 pi over 4, notice they're the same answers for the 45 instead of having to do all the work again. Same answers. See that? Same six answers. Except you notice that 4 of them are negative because the adjacent side is negative. So tangent is opposite over adjacent, cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse, both of them are positive. So in this quadrant, 4 of them are negative and 2 of them are positive. So in quadrant number 2, only sine and its reciprocal are positive. In quadrant 3, only tangent and its reciprocal are positive. So that's going to tell you, it's going to help you a little while where are you at. So if you finish in the second quadrant, everything will be negative except for sine and its reciprocal. If the angle ends in the third quadrant, everything is negative except tangent and its reciprocal. That's an important idea because you'll know what the six answers are from the reference angle that we're dealing with. You'll know what's positive or negative depending on what quadrant you end in. So we're trying to put it all together here. So In quadrant 1, because you're in the first quadrant, suppose, let's say you take the angle negative 300, that's your given angle. This thing ends in the first quadrant, so your reference is 60 degrees. So you have the same triangle, 1 square root of 3 over 2. So the sine of negative 360, the sine of negative 300, cosine of negative 300, tangent of negative 300, cosecant, secant, and cotangent of negative 300 are the same as 60. So these are the same answers for 60. Square root of 3 over 2, 1/2, square root of 3, reciprocal, reciprocal, reciprocal. So these 6 answers are these 6 answers. Real nice, because now sine is opposite over hypotenuse, square root of 3 over 2. Cosecant is adjacent over hypotenuse, 1/2. Tangent is opposite over adjacent, square root of 3 over 1. And then reciprocal, 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 because you're in the first quadrant, everything is positive. So all 6 trig functions are positive. All of them here are positive. All of them. Okay? Now, in quadrant 4, if the angle is 315, we spin around, you have 45 degrees. Now, 45 is 1 hypotenuse of the square root of 2. This 1 itself is negative. So, sine, opposite over hypotenuse, negative 1 over square root of 2. When you simplify, it becomes negative square root of 2 over 2. Cosine is adjacent over hypotenuse, 1 over the square root of 2, and you fix it as square root of 2 over 2. Tangent is opposite over adjacent, so it's negative 1 over 1 is negative 1. Reciprocal, reciprocal, reciprocal. So these essentially are the same 6 as 45. With the exception that what? Again, 4 of them are negative and 2 of them are positive. So in quadrant 4, the only ones that are positive are cosine and its reciprocal. So in quadrant 4, only cosine and its reciprocal are positive. In quadrant 1, they're all positive. Remember a little while ago in quadrant number 2, sine and its reciprocal are the only ones that are positive. And in quadrant number 3, only tangent and its reciprocal are positive. So that kind of leads to this. These are the quadrants where we have the trig value. So all, sine, tangent, cosine. So in this quadrant, all 6 are positive. All 6 trig functions are positive. In this quadrant, only sine and its reciprocal are positive, quadrant 2. In quadrant 3, only tangent is positive and its reciprocal, cotangent. And in quadrant 4, only cosine and its reciprocal, secant, are positive. The other 4 are negative. So a way to remember this is all students take calculus. That's how some people remember it. All students take calculus. So if we come over here, and instead of having to look at the triangle, we kind of just remember how this works. So cosine of 5 pi over 6. 5 pi over 6, remember, is 150 because pi is 180 divided by 3. I'm sorry, I'm over here. 240, excuse me. So 240 is 90, 180, 270. So if 240 lives here, its reference is 60. So I'm looking for the sine of 60. So I go back and I say, okay, what was the sine of 60? Sine of 60 is the square root of 3 over 2. Square root of 3 over 2. So the answer for number 1 is the square root of 3 over 2. However, this ends in quadrant 3. Sine in here is negative. So if I know the trig value for 60, and I know what quadrant this thing ends in, I can get the answer. So there's 2 aspects. What's the answer, and is it positive or negative? So this tells me if it's positive or negative. This tells me the answer. That's all it is. So now going to this one, 300. I'm sorry, 150. Pi is 180 divided by 6 is 30 times 5 is 150. Now 150 lives here in the second quadrant, 30 degrees short. So its reference is 30. So I'm looking for the cosine of 30. Cosine of 30, square root of 3 over 2. But he lives in quadrant 2. So in this one, only sine and cosecant are positive, which means cosine here has to be negative. And that's how you do it. So tangent of 225. 225 lives essentially 90, 180, 225 here. So the tangent of 45. Tangent of 45. Opposite over adjacent. So tangent of 45 is 1. So tangent of 45 is 1, but now in quadrant 3, tangent is indeed positive. So that's why the answer is positive. So the trig value, the trig function will tell you, the angle will tell you what quadrant it ends. The trig function will tell you if the answer is positive or negative. The reference angle will tell you what the actual answer is. Secant of negative 30, secant of negative power 6. Negative 30 is here. So I'm going 30. But now in the fourth quadrant, secant is positive because it's the reciprocal of cosine, so it's the positive answer. But now secant of 30 is the reciprocal of cosine of 30. So 2 over the square root of 3 or 2 square root of 3 over 3. And that's where I'm getting these answers. Cotangent of 300 is cotangent of 60 because 300 falls in the fourth quadrant, 60 degrees short. So cotangent of 30 is the cotangent of 60. Cotangent of 60, square root of 3 over 3. Here. But the negative is because it ends in quadrant 4. So in quadrant 4, only cosine and secant are positive, which means cotangent is one of the other 4. Has to be negative. And then cosecant of negative 330. Negative 330 puts you back in the first quadrant. So in the first quadrant, all the answers are positive. I just got to go find cosecant of 30. Cosecant of 30 is the reciprocal of sine of 30. Sine of 30 is a half. So its reciprocal is 2. The number 2. And that's the answer. And that's how you do all of these that have reference to 30, 45, or 60. You can find the trig functions of radians, degrees, and negative radians and negative degrees. It doesn't matter. As long as it ends in one of these quadrants, and as long as it has one of these reference angles, 45, 30, or 60. And the way it's set up is going to do that. So that being said, I want to show you how we incorporate a circle now into all of this. And I'll get to the bottom picture in a minute. Now, unit circle is a circle that it has a center at 0, 0, and has a radius of 1. It's called a unit because 1 is actually what's called a unit in the world of real numbers. Because when you multiply anything by 1, you get back the same number you started with. So 1 essentially just kind of sits there, kind of like a unit. So the unit circle. So in a unit circle, if the radius is 1, you make a little triangle, a little x and y coordinate, you put a point in the circle. For every point in that circle, the x value is how much you move horizontally, and the y value is how much you move vertically. So now you have an angle that opens up, so you have a theta, so now you have a relationship. So sine of theta would essentially be y over 1. Now, in essence, what they do, this is essentially r, a radius r. So it would be y over r, x over r, etc. But in this particular case, in the unit circle, to make the discussion a little easier, sine of theta is just y divided by 1, or just y. So that tells you that the second number here in the coordinate is the sine of this angle. It's pretty cool on the unit circle. Cosine will be x over 1, or just x. So this tells me then that the cosine of this angle is nothing more than the first number in that point. So x is the cosine of the angle, and y is the sine. So cosine followed by sine. Any point in the unit circle, is the first coordinate is the cosine of the angle that opens to get to that point. And the second one is the sine of the angle that opens up to get to that point. So sine of theta is y, cosine of theta is x. Now tangent is opposite over adjacent. So y over x. So you can kind of see that tangent is really at the same, essentially sine over cosine, y over x. That's sine over cosine. So in actuality, tangent is really sine over cosine. Cosecant is 1 over y. So you can kind of see that the cosecant formally now is 1 over sine of theta. And then secant is 1 over cosine of theta. Cotangent is cosine over sine, or 1 over tangent. So ultimately, cotangent is cosine over sine. Tangent is sine over cosine. So sine over cosine is tangent. Cosine over sine is cotangent. 1 over sine is cosecant, and 1 over cosine is secant. So there's a lot to kind of take in here. There's a lot of information. So we have what's called a unit circle, a full-blown unit circle. And this is what I'm kind of doing here. So as you go around the circle, now I can find values that are here, 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 here. Now, remember a little while ago, it only happens like, what if it ends in one of the quadrants? Well, what if it ends here? What if it ends at this? What if it ends at the x-axis, like 0 degrees? What if I wanted the sine of 0 degrees? Well, now it's pretty easy because sine of 0 degrees is the second coordinate. So sine of 0 is 0. 1 is its cosine. So cosine of 0 is 1. But if I wanted 90, sine of 90 is 1, cosine is 0. But if I wanted 180, sine of 180 is 0, cosine of 180 is negative 1. What if I wanted 270? Sine of 270 is negative 1, cosine of 270 is 0. And then what if I wanted the tangent of 90? Tangent is sine over cosine, so the second number over the first number, 1 over 0, but that cannot happen. So tangent of 90 is actually undefined, so to speak. Okay? But now, what about all these values in between? Well, if I open up this one, I say, well, what if this is 30 degrees? What would those 2 points be? Well, this point would be the cosine of 30, or this and the sine of 30. So I go back. Okay, what is the cosine of 30? Square root of 3 over 2. Sine of 30 is 1/2. So that means in the unit circle, this is the square root of 3 over 2, comma 1/2. 45, I need to know its cosine and its sine. So cosine of 45 square root of 2 over 2, sine of 45 is square root of 2 over 2. So the coordinate is square root of 2 over 2, comma square root of 2 over 2. That's 45. 60, I need the cosine of 60 followed by the sine of 60. Cosine of 60 is 1/2, followed by the sine of 60, square root of 3 over 2. So 1/2 square root of 3 over 2. So these 3 points are on the unit circle now. So at 30, square root of 3 over 2, comma 1/2. At 45, it's a square root of 2 over 2, square root of 2 over 2, comma square root of 2 over 2. And then 60 is 1/2, comma square root of 3 over 2. 90 is easy because on the circle, it's on the x-axis. On the y-axis was 0, 1. That's the coordinate. So now you understand that this is very important because now if I go to the second quadrant, you see 120. 120 has a reference angle of 60. So this has to be the same point as that, even though I didn't draw it symmetrical. It should be in the same level. So these two numbers should be these two numbers. 45 has a reference of, 135 here has a reference of 45. So these two numbers should be the same, these two coordinates. They should be in the same level. 30 and 150. 150 has a reference of 30, so these two should be the same numbers. So these two should be the same. These two should be the same. These two should be the same. The only difference is on the second quadrant, x is negative. So the first number reaches negative. That's where they're getting this. 180 is pretty easy. It's the point negative 1, 0. Now these three, again following by the same reason, 210 should be the same value. As answers is 30. 225 should have the reference of 45, should be the same values of these guys. And then 240 should be the same answer as 60 because they have the same reference angle. Except in the third quadrant, x and y are both negative, so negative, 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 negative. Same answer, same answer, same answer. 270 is the point 0, negative 1. So again, same difference. So 300, same answer as 60, same numbers. 315, reference of 45, same numbers. And 330, same values as 30. Except in the fourth quadrant, the y is negative, so all the second coordinates are negative. And ultimately 1, 0. So all of this is the culmination of everything we've done so far. So on this side, this is what I'm doing here. If you're looking for straight up sine and cosine, sine of 135. 135 is here. Sine is the second number. So sine of 135 is the square root of 2 over 2. 240 now. 240 is here. Cosine, first number, negative 1/2. Done. Negative 300. I'm sorry, negative 30. Negative 30 kind of is over here. Negative 30 is coterminal with 330. So negative 30 has the same answer as 330. So it actually turns out that any angle has the same 6 trig functions as its coterminal angles as well. So negative 1/2 is the sign, the second number. Negative 300. Right here. Cosine, first answer, and you're done. 90, right here. Sine is the second number. Sine is 1. Cosine of 180. 180 is here. Cosine is the first number, negative 1. And so on. Sine of negative 90. Negative 90 is here. So sine is the second number, negative 1. 360. 360 is here. Its cosine is the first number, 1. 5 pi over 4. You can also do radians. 5 pi over 4 or pi over 4 is 45. 45 times 5 is 225. 225 sits right there. I want the sine of 225. It is the second number. And then ultimately cosine of negative pi over 3. This is negative 60. Negative 60 is here. It's coterminal 300. Its cosine essentially here is, and I actually missed that one. Damn. Cosine of negative 60 is the first number, it should be 1/2. And essentially that's how this is done. And I went in with this, the tangent of 210. 210 lives in this point in the unit circle. You can go back to the circle and verify this. Negative square root of 3 over 2 comma negative 1/2. Now, the y value and the x value. So tangent, remember, is sine over cosine, which is the second number over the first number. So I got to do negative 1/2 divided by negative square root of 3 over 2. But when you divide by a fraction, you multiply by its reciprocal. So 2 over the square root of 3. Okay, so notice that the 2's cancel. The two negatives become positive. So it's 1 over the square root of 3, which is really the square root of 3 over 3. And if you look at the big picture here, since the 2's cancel, it's really the top divided by the top. It's really the top of the sine divided by the top of the cosine. So it's really 1 over the square root of 3, or square root of 3 over 3. So tangent is y over x, or sine over cosine. Secant is a reciprocal of cosine. Cosine is the first number. Cosine is negative 1/2. When you flip it, it becomes negative 2. So secant is really the reciprocal of the first number. So 2 pi over 3 lives on this point in the unit circle. Take the reciprocal of negative 1/2. That's what it's saying. Cosecant is really the reciprocal of sine. Sine is the second number. Take the reciprocal of 1/2. Just 2. Just take the reciprocal of the second number. So cosecant would be the reciprocal of the second number. Secant would be the reciprocal of the first number. Tangent would be the numerator of the second divided by the numerator of the first. That's all it is. Cosine of pi. Pi lives on the point negative 1, 0. The first number is cosine, x. Sine of 0 is the second number, so 0. Now, if I want to get the other 4 trig functions, think of secant. Secant of pi is the reciprocal of cosine. So reciprocal of negative 1 is still negative 1. Cosecant, however, is the reciprocal of sine. Sine is 0, so 1 over 0 is undefined. So pi has no cosecant. It's undefined, has no answer for the cosecant. Just want to point that out. What if I want the 6 trig functions of 90? 90 lives in the point 0, 1. So sine of 90 is the first number. Excuse me. Sine of 90 is the y value, the second number. Cosine of 90 is the x value of the second number. Tangent is this y over x, or the sine over cosine, so 1 over 0, which is undefined. Secant is the reciprocal of sine. Cosecant is the reciprocal of sine, so 1 is the reciprocal of 1. Secant is the reciprocal of cosine. The reciprocal of 0 over 1 is 1 over 0, which is undefined. Tangent of 90 is undefined. Cotangent is the reciprocal of 1 over 0, which is 0 over 1. So you have undefined values as well. And really, I should have boxed them all in here. So 90 degrees has some that are undefined, as does 180, as does pi. So what about 270? 270 does in the point 0, negative 1. Sine is negative 1. Cosine is 0. Tangent is sine over cosine. Negative 1 over 0 is undefined. Cotangent is 0 over negative 1. Actually, this is defined. Jeez. This is 0. Sorry about that. Tangent is undefined. Cotangent is 0. So in other words, it's kind of weird to say this, but the reciprocal of undefined is 0. The reciprocal of 0 is undefined. That's not true, but that's how you can kind of think of it. The reciprocal of 0 is undefined. The reciprocal of undefined is 0, so to speak. The reciprocal of 1 or negative 1 is itself. So negative 1's reciprocal is negative 1. So that's how you can find like secant, cosecant, tangent, cotangent. Not just sine and cosine all the time. So this essentially concludes 4.2 all the way to 4.4. 4.2 is the unit circle, 4.3 is the right triangles, and 4.4 kind of puts it all together.